Hello everyone. So we're ready to jump into what will be our last chapter here in statistics for the year. I had you go through the con lessons, kind of some interesting scores I saw for what work you did. So I'm guessing that this has been a little bit challenging, though I think you're going to find it's actually pretty simple, to be honest. So the idea here is called a test for goodness of fit. And as the screen says, we can use a chi-square statistic to test whether a frequency distribution fits into a specific pattern. And they refer to this as the chi-square goodness of fit test. So we're going to break this into two different lessons this week. In the first lesson, which we're going to cover today, we're simply going to look at some different types of problems, and we're going to look at how we determine the expected value and how we write out our null and alternative hypotheses. Then the second part of the lessons will cover the rest of the test and determining whether or not the pattern is actually followed or not. So here we go. Let's jump into it. The chi-square test for goodness of fit formula is actually pretty simple. It says that chi-square, remember that's a notation, not an actual value being squared, is equal to the summation of the observed value minus the expected value. We're going to take that and we're going to square it. Chi-square, if you remember, is variance. So that's where the square comes from. And we're going to then divide that by the expected value. And we're going to sum all those up. And you will see in the second lesson how that actually works. But for this first lesson, we're going to focus on the observed value and the expected value. One final note on this screen is that the degree of freedoms here is found by taking the number of categories minus 1. So we're no longer looking at sample sizes, but rather how many categories did our data get broken into. So problem number 1. So we have a market analyst who wants to see whether or not there's a preference on 5 different flavors of freeze pops. So of course, to answer this question, they go out and they take a sample. That's what we do in stats, we sample. And in this case, they sampled 100 people. And you can see the breakdown in the table of who liked what. And the question here is there a preference among these different flavors? Now, one thing I do need to tell you up front is that our chi-square test is not going to tell us where the preference lies if one exists. It's only going to tell us whether or not there is a preference amongst the different flavors here. So again, it's going to tell us, is there a preference, but it's not going to tell us, is the preference, in this case, cherry? Is it strawberry? Is it cherry and strawberry? Is it, is it the fact that all of them are much greater than grape? It's not going to tell us specifically, but it is going to tell us whether or not there was a preference. And then if there is a preference, there's another test that we'll get into, hopefully called the ANOVA test, which is the analysis of a variance, and it will tell us where that preference lies. So, step 1 in this process is going to be to record both the observed values, and these are the actual collected data. So our observed values in this case are the 32, 28, 16, 14, and 10. So I'm going to make myself a little table on my table, and I've got my values here. I've got a little table started here, and having a little table like this is actually quite useful, as you'll see. What I need to do now is I need to figure out, okay, so these are my observed values. What should have my expected value been? Well, if you think about it for a second, when they asked this question, these 100 people, there really shouldn't have been any flavor that was more prevalent than any others. We're just talking about 5 different flavors of freeze pops here. So there's no logical reason that one of these should have been far greater than any other. Now, you might argue that your favorite flavor is, better than everybody else's, but hey, I would argue mine's better than everybody else's too, and mine might not be the same as yours. So with that in mind, because there was no expectation that one is going to be more than the other, our expected value for each of these categories should have been exactly the same. So with that in mind, in this case, the expected value is going to be found by taking the 100 people that we surveyed and simply dividing it out by the number of categories that we were asking about. In this case, there were 5 categories. So taking 100 and dividing it by 5, our expected value for this problem should have been 20 for each of the categories. So in my little table, I'm just going to go through and I'm going to say the expected value for each of my different flavors should have been 20. All right, so we're ready to actually start our test. Step 1 in our test, as always, to state the hypotheses. And our null hypotheses, I hope you remember this from class, our null hypotheses always states no, or there is no, or no difference, no whatever. So the question was here, was there a preference amongst these different flavors? So my null hypothesis is simply going to state there's no preference. And my alternative hypothesis is going to state that a preference exists. Okay, and that's step 1 in our hypothesis testing process. Our second half of these lessons then will cover the rest of this. So for the first part of this, I'm just going to assign you some problems where you need to go through and find the expected value and write out the hypotheses for the problem situation that you were presented with. All right, onward we go. Problem number 2. Okay, a little bit longer problem here, so we'll summarize it real quick. This group went out and they surveyed some retired people, and they asked them, once you retired, these executives, what did you do? And they were really interested in those that returned back to work. And those that returned back to work really fell into 4 categories here. They were either employed by another organization, they became self-employed, they decided to do some consulting, or they ended up owning their own business or their own company. And you can see that these are the national averages. These are what they saw in general. So Allegheny County decides, well, we want to run this idea and see what are our executives doing. And is there a difference between what our executives are doing and what is going on in the national average? So they went out and they surveyed 300 retired executives. And the breakdown is as follows. 122 were working for another company, 85 were self-employed, 76 were now consulting, and 17 formed their own company. All right, so I need to take this data and I need to create myself a table with it. So the first thing I took note of is that there are 4 categories in this problem. They broke into 4 different groups. We had they made a new company, or they're working for a new company, they became self-employed, they were freelancing or they were consulting, and now they own their own company. And our first line is always going to be our observed values. So in the 300 people that they surveyed, they found that 122 were here, 85 were here, 76 were here, and 17 were here. Now, this time, we're not simply going to take the 300 people and divide them equally amongst the 4 categories. The reason for this is there's no expectation that they should have been equally distributed amongst the 4 groups. In fact, when the national survey was done, they actually broke down into not 25, 25, 25, and 25, but rather the percentages that you see, 38, 32, 23, and 7. So this is going to lead us to our expected values in this problem. So what's my expectation here for somebody working for a new company? Well, my expectation is of the 300 people that I surveyed, that 38% of them should be employed by another company or another organization at this point. So 38% of my 300 people leads me to a value of 114. Self-employed, again, we had a survey size of 300. And in this case, it was 32%. And that gives me an expected value of 96. Freelancing, 23% of those people. 69 was my expected value for freelancing. And who should have owned their own company? Well, there were 300 people in our survey and 7% of the national group, leading us to an expected value of 21. So these are called contingency tables. They're really nice for organizing our data. They're going to be very useful as we move forward into working out the test value for our hypothesis test. All right, the next step in the process, or the first step in the process, is to state our hypotheses. So the question here was, test the claim that the percentages are the same as those in Allegheny County. So I'm simply going to say that there is no difference, meaning they're the same. That's another way of saying they're the same. There's no difference between them. Or, alternatively, a difference exists. Okay. So this is really the two different types of problems you can run into. One where the sample group should be equally broken apart, and one where they give you the percentages and you need to actually calculate the expected value based upon the sample size. I had one final practice problem on the original slides I would have done for you in class, and that was firearm deaths. Excuse me. A researcher read that firearm deaths among people aged 1 to 18 were distributed as follows. She wants to know if in her district there is enough data to test the claim that the percentages are going to be the same. So again, there's no expectation here that these groups are going to divide out equally. Get the hiccups, I hope not. So we're going to first have to figure out how large was the sample size here, because nowhere in the problem did it tell us how big the sample size was. So that's real simple. 68 plus 27, that's 80, 95 plus 5 more. Hey, we're pretty lucky here. They took a sample of 100 people. So this is going to be real simple to figure out what's going on with our expected value, because it's 74%, 74 out of 100. So our expected value for accidental deaths was simply 74%, or 74 of our 100 people. 16 were homicides, so 16%. And finally, 10% of deaths were from suicides. All right. Again, we are supposed to test the idea that the claim that the percentages are equal. So I'm going to go on here, and you can do this in a couple different ways, but we're testing, are they equal? So I can say there's no difference. You can say they're equal if you want to, that they are the same as the national average if you want to. I like following the convention of always using the word no in my null hypotheses. There's no difference. The first one was there was no preference. That kind of keeps me into the same routine every single time of knowing that my null hypotheses always contains the no. That if you remember back from earlier testing, we would test is mu sub 1 equal to mu sub 2? So we were always testing, was there equality in the two of these? Don't want that here. There's no difference. And the alternative to this is that there is a difference. So a difference exists. Okay, so there's a quick summary of the first half of this lesson. I'm going to post for you a worksheet that has on it 4 or 5 problems where I'm going to ask you to go through and simply submit back to me where you calculate up the expected values and type on there what you believe to be the null hypothesis and the alternative hypotheses. I'll return that back to you, and we'll move forward from there as far as the rest of the test. So, be back soon with another video.